We have to apply nodal analysis to find the current I naught in this circuit. We can see there are four unknowns in this circuit, the three node voltages and the current. So also we can see that there is a voltage source between node 1 and node 2. When we have such a situation, we take the node, these two nodes as one single node and analyze them together, and we call this node as super node. We will write one KCL equation for this one nodal equation. So there will be one equation for this node, another equation for this node, so there will be two equations, but we have four unknowns. So I will try writing I naught in terms of other voltages since we want to find I naught. So I can see I naught can be written as V1 over 4, or V1 can be written as 4 I naught. So that's 4 I naught. So let's call it equation 1. Again V1 here can be written V2 plus 10 because of this voltage source. So V2 plus 10, or instead of V1 I will write 4 I naught, V2 plus 10. So I am trying to write V2 in terms of I naught now. So V2 will be 4 I naught minus 10. This is equation 2. Now writing the supernode KCL for this supernode, there are four currents connected to this node. I will write the outgoing currents as positive. So I naught is an outgoing current, 2 is an outgoing current. This outgoing current will be V2 over 2, and this one will be V2 minus V3 over 10. So for supernode, I naught outgoing, 2 outgoing, V2 over, was it 2? Yeah, 2, plus V2 minus V3 over 10 is equal to 0. So we can multiply both sides by 20 to get rid of the fraction. We get 20 I naught plus 40 plus, that will be 10 V2 plus 2 V2 minus 2 V3 equals to 0. So 20 I naught plus 40 plus 10, instead of V2 I am writing 4 I naught minus 10 in terms of I naught. These two when added will be 12, so I will write 12 directly, and then minus V3 here, 2 V3. So while adding it will be 20 I naught plus 48, so 68 I naught minus 2 V3, and on the other side will be, here it will be minus 120 plus 40, so on the other side it will be 120 minus 40, so 80. So that's equation 3. Now writing KCL for the last node V3, for the other node, the third node. 4 amps is an incoming current, 2 amps is incoming, and the other these two are incoming, so there will be negative if I write in terms of the outgoing currents as positive. So here the outgoing will be V3 minus V2 over 10. So node 3, minus 2 minus 4 plus V3 minus V2 over 10 equals to 0. Multiplying both sides by 10 will give me minus 60 plus, V3 minus V2 over V3 minus V2 is equals to 0. So V3 minus V2 equals to 60, or I can write minus V2 I can write 4 I naught minus 10 plus V3. So this is becoming minus 4 I naught plus 10 plus V3 equals to 60, or minus 4 I naught plus V3 equals to 50. That's equation 4. So now we can, if we look at equation 3, here is minus 2 V3 and this is plus V3. So I will do 3, equation 3 times plus 4 times 2. 4 times 2 plus 3. 68 I naught, this is 4, this is 3, minus 2v3, minus 2v3 equals to, it was 80. And this one will multiplied by 2 becomes minus 8 I naught plus 2v3 and 100. So when added, these two get cancelled. This is 60 I naught and this is 180. So I naught is 180 over 63 amps. So that's the desired value of I naught.